Alright, in preparation for us solving systems using matrices, we have to practice what are called row operations on matrices. And so here is a system. We've already seen how we can solve this system using elimination. But we're going to start solving them using matrices and manipulating matrices in a special way. And that involves what are called row operations. So, first notice that the matrix associated with this system is over here on the right. All right, I've got my coefficients in the first three columns, and then here in the right column I have my solutions and my answers. And so this is sort of, you can view as representing the x column, that's the y, and that's the z. So I'm going to call this row 1, this row 2, and this row 3. Now I'll talk more about what our goal is in the long run in another video, but for now I just want to get some practice with notation and what I mean by row operations. So row operations really just means adding rows together to produce new rows, or replacing old rows with new rows when you add them together or multiply and add them together. Very similar to when you're solving a system by elimination, right? Sometimes you multiply an equation by, you multiply this equation, for instance, by 2, and you do that because you want to get rid of the x's, right? You multiply it by 2 and then add the equations. We're going to do that. We're just going to be using matrices instead. So that's really what this is all about. So let's start with this example. Let's do row 1 plus 2 row 2. So what does that look like? Well, what it means is to add row 1 to 2 times row 2. Now, first thing you should notice is that row 3 is not involved in this at all, so I'm just going to copy row 3 down as it is. There's row 3. Now, row 1 plus 2 row 2. So row 1 is up here, we can see it, we leave it as is. Row 2 we have to multiply by 2, so what I'm going to do is I'm going to write it below, right below row 2, just in white. So 2 row 2 means multiply all the entries by 2. So this 1 becomes a 2, that's a negative 4, that's a 6, and 0 times 2 is 0. Now I'm going to add row 1 plus 2 row 2. So that means negative 2 plus 2. Now when I add them together, the question is, where do I put the answers? You have a choice, but I'm going to put my answers in row 2. And so I'm going to replace my old row 2 with the new one. So I'm just going to put a little arrow here to indicate that that's where the changes are happening. Negative 2 plus 2 is a 0. 1 plus a negative 4 is a negative 3. Negative 1 plus a 6 is a 5. And 2 plus a 0 is a 2. Alright, and I'm going to leave row 1 as it is. So there it is. Let's do another one. How about 3 row 1? 3 row 1 plus 2 row 3. Let's use another color here. So now I got to do 3 of row 1 plus 2 of row 3. Well, I'm also going to note that row 2 is not at all involved. And again, none of this relates to problem 1. Problem 1 is done. We're still referring to our matrix above up here. So row 2 was not involved, so I'm just going to copy that down as it is. It wasn't involved in that row operation. Let's do 3 row 1. And actually I'm going to cross off this in white because that was from the last problem. 3 row 1 means multiply all the entries of row 1 by 3. So this becomes negative 6. This becomes 3, negative 3, and a 6. And then I'm going to write 2 row 3 below it. So I'm going to multiply row 3 by 2 to get a 6, 2, negative 2, and a 4. And now I'm going to add them together. So negative 6 plus a 6 gives me a 0. And again, you can replace either row 1 or row 3. I'm choosing to replace row 3. And I'm going to leave row 1 as is. So again, it doesn't matter which one you change. But I'm choosing to do it this way. So negative 6 plus a 6 is a 0. net 3 plus a 2 is a 5, negative 3 plus a negative 2 is a negative 5, and 6 plus a 4 is a 10. And I'll leave row 1 as it was above. Great. Okay, let's do one more example. How about, let's just do a good old adding two rows together. So I'll cross those off here. So let's just add row 1 plus row 2. Now that operation does not change row 3, so I'll just leave that as is. And then I'm going to add row 1 to row 2. I can change either one. I'm just going to change row 2. So row 1 plus row 2 is negative 2 plus a 1 gives me a negative 1. 1 plus a negative 2 is a negative 1. Negative 1 plus a 3 is a 2. 2 plus a 0 is a 2. And I'll leave row 1 as it is. Alright, so that's basic row operations. So the one question is, what's the point of all this? Well, the point is that what we're essentially doing is what we were doing when we were solving systems, right? When you solve systems, as I mentioned, if you wanted the x to cancel over here, you'd multiply by 2, and then you'd add the equations together, and your x variable would vanish, right? So by doing that repeatedly, or as much as possible, you're sort of reducing the complexity of the problem until you can find out what x, y, and z are. So these row operations, all it is just doing the same thing, but without writing the x, y, and z's, because as long as they're in the right columns, right, as long as you understand that like the first column is x's and the second column are the y's, and the third represent your coefficients of the z's, as long as you understand that, you kind of don't need to keep writing the x's and the y's. All right. So that brings me to another point, which is that in problems 1 and 2, something nice happened that did not happen in problem 3. What happened was that we produced a 0 as one of our first entries there. And that, again, remember what that means is that the coefficient of our x, in this case, is a 0. So we've chosen the right operation to eliminate one of the variables. And in a future video, you're going to see me expand on that idea more. Row 3, we did a row operation, but it kind of didn't make the problem, or it didn't make the matrix like more simple, right? It didn't give us any zeros. Zeros are good because they correspond to variables kind of vanishing and helping us get closer and closer to solving for x, y, and z. So I'll leave it there for row operations, and we'll pick this concept up in the next video.